This is going to serve as a review for those that may need a little bit of help factoring, understanding what it means to factor a number, and to find the greatest common factor. So we're going to start with the basic definition of factor by using an actual example. So let me write it down. 2 is a factor of 6, and you know that, and I know that, but here's the reason why. If I had 6 things, I can split them into 2 groups. There's a group and there's a group. So because I'm able to split this into 2 even groups, two groups that are the same amount, 2 groups both of 3, because I'm able to do that, 2 is a factor of 6. Okay, well that's fantastic. Now let me define what a factor is. A factor is a number that divides evenly into another number. When I say evenly, I don't mean even as in an even number, but I mean it goes in a certain number of times with no remainder. Again, another example, you know this, but just to lay the groundwork, 5 is a factor of 25. So if I wanted to, I could say, well, 5 goes into 25, well, 5 times, and if we went through the whole process, 5 times 5 is 25, and we'd subtract and we'd get 0, so there would be no remainder whatsoever. Okay, the next thing is to define what a prime number is, and you've heard this, but I just want to reiterate it with this in mind. And a prime number is a number that has no factors other than 1 in itself. For example, 7 is a prime number. So if I have 7 things, 1, 2, 3, 4, 5, 6, 7, I have 7 students in class. That'd be a nice size class. But if I have 7 students in a class, I cannot put them into equal groups other than one group of 7 or 7 individual groups, which is not really much of a group. That basically means everybody's working along. So I could either say everybody works by yourself, or we'll work all as one group of 7. But I can't say, okay, we're going to have 2 groups if we're going to have the same amount in both groups. Or I can't say we're going to have 3 groups if we're going to have the same amount in all of the groups, because 7 doesn't work that way. All right. So then, from there, what we're going to do is I'm going to give you a short list of prime numbers. For example, 2 is prime, because if I have 2 people, I can't have anything other than one group of 2 or 2 groups of 1. 3 is also prime. 4 is not prime, and the reason it's not is because if I have 4 things, I can put them into 4 groups of 1 or 1 group of 4, which is fine. But I could also put them into 2 groups of 2. So because I'm able to split them up in an equal amount, I can't say that 4 is prime. But 5 is prime. 6 is not. 6 is an even number. No even number is prime except for 2. 7, we've already talked about that. 7 is prime. 8 is even. 9, I could, if I had 9 students, I could have 3 groups of 3. So 9's not prime, 10 is not prime, 11 is prime, 12 is not, 13 is, 14, no, 15, no, 3 times 5, 16, no, there's a lot of options with 16, 17 is prime, 18 is not prime, 19 is prime. And we're going to continue on from there. It goes on infinitely. There's an infinite number of primes. We're going to stop there. 23 is prime. 29 is prime. 31 is prime. Okay. We are going to list the factors of a number, and we're going to talk about 2 different ways of writing factors. We can have a list of factors, or we can have a prime factorization. So first thing we're going to do is list the factors. List the factors of 18. Okay, so here's what we're going to do. I have 18 students in a class. If I have 18 students, I could have one group of 18 students. And alternately, I could have 18 groups of 1, which again isn't much of a group, but everybody is in their own little group by themselves, if that is even a thing. So I can have one group of 18. I can have, it's even, because it's even, 2 goes into it, I can have 2 groups of 9 Okay, does 3 go into this? And yes, it does. So really quickly, let me tell you how I know that. Well, because I know that, and you know it too, but just very quickly. If I want to add together the digits of a number, and get another number, if 3 goes into that, then 3 goes into that. So 3 goes into 9, therefore 3 goes into 18. So I know 3 goes into it, and we sort of knew that anyway because of basic multiplication facts, but 3 goes into 18 6 times. 4 does not. 5 does not. And 6 does. We've already listed it, so there we go. There's our list. Now there's a big gap in the middle. Sorry about that. I didn't space it correctly, but 1, 2, 3, 6, 9, and 18 are all numbers that go into 18. Really quickly, let me review. 18 is not prime. Otherwise, my list would be very short. It would just have 1 and 18. But there's more than just that goes into it. Okay, so this was a list of the factors of 18. But now, down here, I'm going to write the prime factorization of 18. Write the prime factorization of 18. Okay, so here's what I'm going to do. I'm going to take the number 18 and I'm going to split it apart. And I say split it apart, I'm using division. So I need to divide something into it. I need two numbers that multiply together to give me 18. Now, 1 and 18 works, but it's not helpful. So let's avoid 1 and the number itself. So two numbers multiply to give me 18. I have a couple options. I could do 2 and 9, or I could do 3 and 6. I'm going to go with 2 and 9, just because. So 2 times 9 is 18. If I come across a prime number, just for my own purposes, I'm going to circle it. So 2 is prime. 9 is not prime. I know there are numbers that go into 9 other than 1 and 9. And it would be 3 times 3. And this is the prime factorization of 18. Sometimes you may want to write it like this. 2 times 3 times 3. So technically there are two of them. That's why we have exponents. Okay? So we're going to do this again with a different number, and then we're going to talk about greatest common factors. So divide those things up. And the next number we're going to deal with is 24. So we're going to list the factors of 24. And when we do so, we're going to start with the obvious. Well, 1 goes into 24 times. We'll put a little gap there because there will be numbers that we're going to fill in between. So in order to fill these numbers in, we have to just start counting. Okay, 1 goes into 24. 1 goes into any integer. Does 2 go into 24? Well, it's even, so yes. How many times does 2 go into 24? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It goes in 12 times. You can count by 2s to get there. Okay, does 3 go into 24? Yes, it does. Again, real quickly, here's how I know. 24, we're going to add 2 plus 4 and we get 6. 3 goes into 6, so 3 better go into 24. And it does go. It's not erasing very well, is it? There we go. So 3 goes into 24 8 times. 3, 6, 9, 12, 15, 18, 21, 24. 8 times. Okay? Does 4 go into 24? Yes, it does. 4 goes into 24. 4, 8, 12, 16, 20, 24. So 6 times. We counted as 6 as we counted by 4s. List is crooked, I'm sorry. But that is the list of the factors of 24. How do I know I'm finished? Because if we kept counting, we'd go to 5. 5 doesn't go into 24. 5 goes into 25, but 5 doesn't go into 24. So because 5 doesn't go into it, and when I say go into it, what I really intend is there is no remainder if I was to divide it into it. I mean, it goes in there, but it would give us a decimal or a fraction, depending on your perspective. So when I say it doesn't go into it, it does not give us, it gives us a remainder of 0, basically, if it goes into it. So let's do the prime factorization of 24. So write the prime factorization of 24. So here's what we're going to do. We're going to take that 24 and break it up into two separate numbers that multiply to give us 24. So 24 is, well, let's just go for the first thing we see other than 1 and 24. 2 and 12, okay? 2, oh man, 2's prime, yay. 2 times 12. 12 is not prime. What two numbers can multiply to give me 12? I have a few options, but one of them is 2 and 6. I could say 3 and 4. Let's do 3 and 4, just because. 3 is prime, 4 is not. 4 splits up into 2 times 2. So our prime factorization is 2 times 3 times 2 times 2. We can put them in a different order. I'm going to. I'm not expecting you to write it like this at this point necessarily, but do understand that if I had 2 times 2 times 2, that's 3 2's, 2 to the third, times another 3. Then if I did all that, then I would get 24. 2 times 2 times 2 is 8. 8 times 3 is 24. That sure enough works. Okay, so here's what we're really going to do. We're going to find the greatest common factor between 18 and 24. I don't have much space. I'm going to squeeze it in down here in this tiny little space. So find the GCF between 18 and 24. Okay, here's the easy way. Well, the super easy way is, and this is what I'm trying to develop, the super easy way is to look at the numbers and just intuitively know it and stare at it and say, I know what goes into both of those. And that's what I'm trying to develop. So this process is hopefully developing that thinking pattern in you. But if you're not there yet, that's fine. There's no criticism. But let me point out a super easy way. Find the largest number between these two lists that they have in common. Sometimes that number is 1. In this case, that biggest number that they have in common is 6. So the GCF is 6. Find the GCF, well, it's equal to 6. Okay, let's do it a different way. Suppose you don't list all the factors. Suppose you do the prime factorization. What we're going to do is find pairs that they have in common. And we're going to mark them out as we go. So what do we have over here? Prime factor. That's also over here. Oh, we have a 2. They share a 2. Okay, great. Put a 2. What else do they share? Oh, there's a 3 here and there's a 3 here. Okay, fine. Put a 3. Now we're going to multiply them. My handwriting got terrible there, didn't it? Is there anything else they share? No. This one has an extra 3 that this one doesn't have. This one has 2 2's and that one doesn't have any more 2's. So all we have is a 2 times 3 and it's 6. So it'll work the same either way. Okay, we're going to do a couple more of these. And the last one's going to be a little bit tricky. Alright, we're going to do 21 and 12. And we're going to do it both ways. You can pick whichever way makes the most sense to you, or you can do it your own way. If you can just look at it and tell, that's fine. Go for it. Again, that's what I'm trying to develop in you, to where you don't have to list these things. You just know it. You can look at it and say, 6 goes into that, 6 goes into that, and I know that's the biggest thing that goes into both of them. Okay, we're going to do 12 and 21. 21 and 12. In no particular order. I'm going to just start right here. Okay, so I'm going to list the prime, I'm going to list the factors, not just the prime factors. I'm going to list the factors of 12. So list the factors of 12. Okay, anytime I do that, I know I can start with 1 and the number itself, 1 and 12. I'm going to put them in order, so we'll put a gap in there. Does 2 go into 12? Oh, yes it does. And it goes 6 times. Does 3 go into 12? Oh, yes it does. And it goes 4 times. Does 4, oh wait, yes, it's already on our list. That's the whole thing. We're done. So now we're going to write the prime factorization. Prime factorization of 12. And that's going to be when we put the number 12 and we split it up. Because 12 is not prime, we're able to go further down. And we will. 12, we did this actually just a minute ago. It's 2 times 6. I think we did 3 times 4. We'll get the same answer either way. 2 is prime. 6 is not. 6 is really 2 times 3. And we're finished. You can write it as 2 times 2 times 3 if you like. I'm going to leave it here for the sake of where we're going next. Alright, same problem with a different number. So we're going to list the factors of 12. I'm sorry, list the factors of 21. 1 goes into 21 times. 2 does not divide into 21 evenly, not an equal number of times. 3 goes into 21 7 times. 4 does not go into 21. 5 does not go into 21. 6 looks like it would, but does not go into 21. 7 is already on our list. That's it. You can probably look at it right now and tell what the greatest common factor is. I think it's fairly obvious if we look at these two lists and find the largest thing that they have in common. I won't blurt out the answer, but it's kind of staring you in the face. Okay, so let's write the prime factorization of 21. This one's going to be fairly straightforward and short. Two numbers multiply to give me 21. 1 and 21 doesn't help. It will get me nowhere. So let's do 3 times 7, and they're both prime, so we'll stop. Okay, again, what's the largest thing that they have in common? 3. What do they have in common if we do it the other way? Then they have a 3 in common. So I can say that the greatest common factor between these two numbers is 3. All right, let's do one more example. That example is going to be 11 and 15. So I'm going to erase this. Erase that. Let's erase that, and erase that. Okay, 11 and 15. So we're going to list all the factors of 11 and write the prime factorization of 11. List the factors of 15, write the prime factorization of 15. Again, you don't have to do it both ways, but I'm demonstrating both ways so we can understand the process, understand the concepts behind it too. So, list the factors of 11. Well, 1 and 11. Okay. 11, already told you, it's prime. 2 does not divide 11. 3 does not divide into 11. 4, no. 5, no. 6, no. 7, 8, 9, 10, no. 1 and 11, that's it. Okay? Prime factorization of 11. Two things multiply to give me 11. The only option I have is 1 times 11. I'm going to write it, although it's unnecessary. 1 times 11. That one's prime. I really didn't have to write that. I could have just said, you know what? 11 is prime. There is no prime factorization anyway. It is prime. That's it. Okay. Factors of 15. 1 and 15. 2, no. 3, yes. 3 times 5. 4, no. 5, already on the list. We're done. Okay? Prime factorization of 15. 15 is really 3 times 5. So now we get down to the other question. What is the greatest common factor between these two numbers? Well, let's do it this way first. What do they share? Nothing. They share nothing. That does not mean the answer is 0, because the greatest common factor is the largest integer, regular counting number, no fractions, no decimals, the largest counting number, largest integer, that I can divide into 15 and 11. Well, they don't have anything in common, and so the only thing that goes into both of them is obvious in this list, and that's a 1. So the GCF between these two numbers is 1.